Now, I want to tell you like what is simple linear regression.
So is the simple linear regression when it fits on a straight line?
Yes. So,
Okay.
if like we have data, investment and profit. So, if we will put that data on a graph paper, if we will get a line like this, then we call it linear regression. And if we get a line like so if we get a straight line, we call it linear regression. And if the line is like this, not only like this, wherever the point is, so we call it non-linear.
Non-linear.
Now, what is the equation of linear regression? See, there are like when we study econometrics, before that we have to know the knowledge of statistics. Okay, so in a statistical language, we write the equation like this: y equal to a plus bx. But in econometrics, we write this equation by using beta. So when we see above equation, it is the same as the below equation. Both are same. But in statistical language, we use y equal to a plus bx, and in econometrics language, we write this equation as y equal to b1, like beta 1 plus beta 2x. So a is beta 1, b is beta 2. Now, what is y?
Y hat.
Huh. Like we don't write every time y hat. Sometimes we write y hat, sometimes we don't write y hat, but it is always estimated.
Okay.
Now, y is dependent variable, that y is, in our example, it is profit, and x is investment. Now, what is beta 1 and beta 2? If we are writing capital beta, if we are written small beta, both are okay. There is no change, like there is no different meaning. If we can write capital beta like in this way, or we can write in small form, both are same.
Okay.
But what is beta 1 and beta 2? These are the parameters which are constant. Now, what is a parameter? Like we can say these are the fixed cost. Okay, so A is fixed cost, like beta 1 is fixed cost. Like if we have a showroom, and a showroom of cloth garments, and we have to pay some rent for that. So rent amount is beta 1, which is fixed cost, which is always fixed. But beta 2 can be calculated. What is beta
Okay.
1? It is fixed cost. In our
Yes.
example, it is fixed cost, which is always fixed.
Yeah. So the beta one is fixed cost. That's representing the parameter.
Yes. And beta 2 is like x changes when beta 2 changes. X is a dependent variable, like rate of investing. We can say rate of investing. If we invest every time in 2x zone, like we always, when we invest now, we invest 10,000. When we invest another time, we invest 20,000. When we invest third time, we invest 30,000. So always we invest 10,000 more. So beta 2, B2 is rate, how we change our independent variable, the rate of changes. So rate of change, how we change our, like every time we do something, we do the double. We always do the double. So it is 2 because we always do double. So it is the rate of change, how we maintain a pattern. So it can be given in the sum or we can calculate it. It has formula how to calculate beta. Okay. Now, I'm again using that equation. Now, this we can understand, like if our x will change, our y will also change. How x will change? We know that if beta 2 is 0.40, then x will change every time. So if
Mhm.
x will change, y will also change. For
Yeah.
example, I am writing that thing. So if my fixed cost is 1000, so beta 1 is 1000 and beta 2 is 0.40, like always we invest 0.40 of amount and our initial investment is x, which is 10,000. Now if our initial investment will be 10,000, we will earn a profit of 5,000. We have
Mhm.
concluded this, that if we will invest 10,000, we will earn 5,000. Now
Yeah.
in the next month, you want to predict if you will invest 4,000 more, 0.40 amount of 10,000, if we invest more, how my profit will behave. So, beta 1 is constant. So, beta 1 will always 1000. Our second investment is 14,000 because we have invested 4,000 more. So, if we will invest 4,000 more, we will increase 2,600. So, if our investment will be 14,000, our profit will be 6,600. So, we can see that beta 1 and beta 2 is constant. It has not changed. But X changed, Y also changed. So, when we change our investment, we will change our profit. Now, you can see over any book, in the book, that there is an error term. E is there.
Yeah.
Now, what is this error term? What is this error? Error is when we predict something, definitely there will be some error. Error is inherent to every situation. Like inherent means it is always present. Like if there is a rainfall, you carry an umbrella, but you can protect some part of your body, but cannot be 100% protected. You will wet your body in some way. So there is an error in umbrella. So there, like nothing is flawless. Like my teaching is also not flawless. There is zero error. It cannot happen. Like in my teaching, in every situation, there is an error. So in our prediction, there must be some error because we have predicted that if we will invest 10,000, we will earn 5,000. If we will invest 4,000 more, like if our total investment will be 14,000, our profit will be 6,600. So maybe our prediction has some error because definitely we can't earn exactly 6,600. Like if we will prepare for the exam, we predict that according to my preparation, I will we will get 80 out of 100. But it's our prediction according to our preparation. But maybe we will get 75, maybe we will get 85. It may happen that we will get 80, but its chance is very less. So this chance is called the error which we have done. If we predicted 80 out of 100 and if we got 79 out of 100, there is an error of 1. So this is the error term. So our complete equation is like this. E is error term. We can calculate error term, but it is always present in, if you will put all the data into the software, it will calculate for you the error term. Now, what the page I have shared with you. So what is simple regression analysis? Simple regression analysis is generally called regression model. It has two objectives. It establish if there is a relationship between two variables. Relationship is either positive or negative. Positive means if one variable increases, another variable also increases and vice versa. Negative means if one decreases, another will also increase. There is a statistically significant relationship between the two. Example, income and demand. When our income increases, demand will also increase, and sales and profit. And forecast new observation. This is the main thing. Forecast new observation. Dependent variable, independent variable, meaning simple regression model is also called linear regression model because we use linear equation y equal to a plus bx. In stats, we use different notation. Y equal to beta 0 plus beta 1 x. I have uses beta 1 plus beta 2. You can use beta 0 plus beta 1. In books, we get this equation, beta 0 plus beta 1 x. Beta 0 is intercept or constant. Beta 0 is always constant. But beta 1, coefficient of x or the slope of x. Coefficient of x means x will always change according to beta 1. Now, we will call it linear because they will appear as a straight line if we plot them on a graph. Now, it is like this. I am explaining you this thing. Now, what this diagram says. Now, when we use this equation and if we get a straight line, we call it linear equation.
Okay.
Now, what does this error term? When we have predicted our data, we got a straight line. After prediction, we got a straight line. But when we got the actual, like when 2022 has come and we saw that profit is not 6600, profit is 6400. So now where I will plot? We will plot here for the first year. Now second year also the prediction has some error. So we got the dot here. Now in this way, we got all the dots. Some dots are on the predicted line, but some dots are below or after, below or above this line. So now what is error? The distance between, like the distance between estimated and actual one is error.
Okay.
So the distance between the predicted and the actual data, like we have predicted 6600 and we have actual profit is 6400. So 200 is the difference, that is the error. So error is the difference between the predicted and the actual data or whatever. So this is the error. So here I have written all these things very clearly,
Okay.
like I have shown in the picture that what is error. So I have written E. Now example, beta 0 is 4, beta 1 is 2, y is equal to 4 plus 2x, where 4 means distance from the horizontal axis. Now what is beta 0? Beta 0 is the distance between, it is called intercept, the difference between the x-axis and the line. Okay, this is beta 0, the distance between horizontal axis at which the line crosses the vertical axis in the case. If x is 0, then y is equal to 4. If there is no variable cost. Can you understand variable cost?
Yeah, I understand.
Okay, so if there is no variable cost, x will be 0. But y cannot be 0. Why? Because there is some fixed cost of your business.
Yeah.
So y cannot be 0. So
Why would
if one variable is 0, like independent variable is 0, still dependent variable cannot be 0. We see here that the line is crossing the vertical axis 4 units above the horizontal axis. Slope here is 2, and it means every unit increases of increases of x, y will increase twice. Okay, so if beta 1 is 2, it means when x will increase, y will increase twice. Okay,
Okay.
because it is 2. It is times, 2 times. Now, not every time line is intersecting or passing across any of these dots. Like we have seen that every time my predicted value is not the actual value. So error exists. So we have to minimize these error by calculating. Now, what is our main goal? What is our main objective? We know that we cannot remove error because error will exist. We can't remove error 100%. There always be some error, but we can do one thing. We can minimize the error. We can
Okay.
we can minimize the error by studying econometrics. So y is equal to this equation is there. E is error, but in Greek term it is called epsilon. So
Oh, okay.
wherever you study epsilon, it means error. Now, example from an actual data, we will try to explain a family's consumption of a given product. Now, I I'm trying to explain your family consumption for a product, say rice. We have 40 data of 40 different families. Like we have 40 different families and we have 40 data. Like this family consumes 2 kg of rice, this family consumes 10 kg of rice. In this way, we have 40 different data of 40 different families and their weekly income and consumption. So Y is consumption and X is income. Okay.
Okay.
Now we can use this equation in any of the following in any of the data. We can use this.